All right, cool. So as I mentioned, today we're going to be reviewing nomenclature rules in organic chemistry. This tends to be a pretty strong point for students in this course. It's a great place to clean up points. Basically, as soon as you get these rules down pat, adding on like an additional one here or there is not a big challenge, okay? So we're gonna go over our basics that we need to have here today, make sure we understand how to do this going forward because we're gonna build off of it, all right? We're going to start first. We need to have this correspondence between our number of carbons and our prefix that we use in this course. All right, and so what I'm going to expect you all to have memorized here is up to 10 carbons. All right, so let's see who can remember here. If I have one carbon, what prefix do we use? Meth. What about two carbons? F. Three carbons? Prop. Four carbons? Bute. And these four are really unique to chemistry. The rest of them you'll see in places like geometry and stuff like that. For 5, it's pent. 6 is hex. 7 is the one that everybody seems to fumble. 7 is hept, H-E-P-T. 8 is oct. 9 is non. And 10 is dec. All right, so this is how we're going to refer to the number of number of carbons that we have in our molecule. We'll use these prefixes here. Okay. So now we're going to talk about our nomenclature rules. Whenever we go to name a compound, we always apply these same 4 steps. All right, let's get an example going on the side here. Okay. Step 1 is we need to find our parent chain. All right, a parent chain in an organic molecule is the longest continuous set of carbons. So our parent chain in this very simple straight chain alkane here is just our 5 carbons. All right, so which prefix would we use? Pent, right? 5 carbons. All right. Now the suffix that we use depends on our functional group. For alkanes, as well as cyclic alkanes, and alkyl halides, what suffix do we use? Ane. All right. Depending on what functional group we have, we would change our ending here. These are the 3 that we're going to go over today. They all use that same ending A-N-E. You also would have talked about nomenclature of alkenes last semester. Actually, our first chapter will be on conjugated dienes, molecules that have 2 double bonds in there. So that's like a perfect time to review that. So I'm just going to stick to these 3 here today. or we're going to use this ANE suffix. And in this case, since this is just a straight chain alkane, that's all I need to finish off the name of this molecule. This would be our 5 carbons, pent, followed by that suffix ane. All right, so this would be our pentane here. I'm going to make this a little bit more complicated now so we can introduce our other rules that we need for nomenclature. Okay, so we're going to do this example next. Everybody can take a second and apply rule 1 though. Find that parent chain for me. All right, what do we got? How many carbons are in our parent chain? Cool, so I tried to be a little bit tricky here by making everybody think that they would just be reading left to right again. But no, we got to find the longest continuous set of carbons. That would be these 6 right here. Okay, so my parent chain in this molecule is hexane. But the entire goal of nomenclature in organic chemistry is to uniquely point to a molecule, right? So all carbons in this molecule have to be accounted for in my name, which means I gotta account for this one over here as well when I name my molecule. All right, so this is now when we move to rule 2. I'm gonna leave a little bit of room here because I'm gonna add to this, complicate things a little bit. But the next step would be to find and name what we call our substituents. All right, your substituents are anything that points off of your parent chain. For what we call alkyl groups, right? Alkyl groups are when we just have carbons and hydrogens in that substituent, all single bonds, as in this case here. In order to name those, we do our number of carbon prefix plus the ending YL. All right, so in my substituent up here, I have this 1 carbon. We use that prefix meth. And since it's an alkyl substituent, I toss that YL ending on it. This would be a methyl group. Again, I'm going to leave a little bit of room to talk about alkyl halides. Move on to step 3 here, which is to number your parent chain. All right, we call those numbers the locants in organic chemistry. And I got 2 different ways I can number my parent chain. I can go left to right, or I could go right to left. And which one of these numbering schemes is correct? Red or blue? Blue. And why is it blue? Lowest number, right? That's the name of the game here. We want to build the lowest number into our name. Okay. Again, I'm going to leave some room to complicate things. The last step is to assemble our name. And we want to do our locant dash substituent. And then our parent chain. okay? So to finish off this molecule here, as we said, we're going to pick that blue numbering scheme, giving that locant, giving that methyl group the lowest number. So this would be 3-methyl hexane, all one word, all run together, no spaces in your name. Okay, so we're going to find our parent chain. Then we're going to find and name our substituents. We're going to number our parent chain, and then we're going to assemble our name. All right, and these are the same 4 steps that we're going to do for every molecule that we encounter. Okay, so before we complicate things, get to some special cases here, I want everybody to take a second and name these 2 molecules for me. All right, so let's do it. So for this one here, how many carbons in my parent chain? 5 carbons in my parent chain, and I got these 2 carbons sticking off of that parent chain, so my substituent here. What would I name my substituent? This is an ethyl group. I'm going to number my parent chain. In this case, it doesn't matter which direction you go. You'll always have that ethyl group on carbon 3. So when I assemble my name here, 3-ethyl pentane. Okay. How many carbons in my parent chain of this next example?
8.
All right, so again, try to be tricky here, but our longest continuous set of carbons are these 8 here. So my parent chain would be an octane. That means that these 3 carbons here are my alkyl substituent, and I would name that a propyl group. All right, I'm going to number my parent chain. You go the other direction. And which one of these numbering schemes am I going to pick? Red or blue? Blue, because I want the lowest number for that propyl group. Okay, so this would be 4-propyl octane. Again, ran together, all one word. So far, so good? Cool. All right. Let's do 2 more examples here. Now we're going to introduce a halogen into our molecule. All right, so we're going to do these 2 here. All right, as always, I'm going to find my parent chain, my longest continuous set of carbons. All right, so my parent chain here is a propane. And alkyl halides are kind of weird in that respect. They're very much so a different functional group than alkanes. Normally when we have a new functional group, we're going to change the suffix of our name here, of our parent chain. Alkyl halides, for whatever reason, they don't do that. They build the halogen in the beginning of the name as a substituent, all right? So this functional group is kind of weird. It's treated as a substituent as opposed to changing the back half of the name, which is what we're going to do for every other functional group that we encounter, all right? So instead, again, I treat this like a substituent. So how do we name our our halogen substituents? Right, so it depends on the element. In this case, we have that F. So fluorine is a fluoro group. Chlorine is a chloro group. Bromine is a bromo group. And iodine is an iodo group. All right, so I left a little bit of room under Rule 2 here so we could also include our halogen substituents. All right, all of our other rules are the same. So we name this as a fluoro group. I'm going to number my parent chain. In this case, it wouldn't matter which direction I went. My fluoro group will always be at carbon 2. So this would be 2-fluoropropane. Okay? Cool, let's do this next one together. So, how many carbons do I have in my parent chain? 5. So this would be a pentane. This substituent up here is what? Chloro group. This substituent down here, that's my favorite, a bromo group. We're going to number our parent chain. 1, 2, 3, 4, 5. We could go the other direction. 1, 2, 3, 4, 5. When you have multiple substituents, sometimes it's helpful to list your locants off to the side here. So my blue numbering scheme would be a 2 and a 3. My red numbering scheme would be a 3 and a 4. So which one am I going to pick? The blue one. Okay. But now we have to assemble our name here. All right, so when we go to assemble our name for multiple substituents, we put those substituents in alphabetical order. So not in the order in which they appear in my molecule. Yes, the chlorine is on carbon 2 and the bromo group is on carbon 3. But when I assemble my name, I'm always going to assemble my substituents in alphabetical order. So I'm going to list that bromo group first. 3-bromo. Then my 2-chloro. And then my parent chain, my pentane. All right, so our substituents, they go in alphabetical order in our name. Again, we have no spaces. Let's just note that our dashes are always separating the numbers and the letters in our name. Okay, let's do another example. Put down 2 more here. All right, so if we're going to do this first one here, how many carbons do I have in my parent chain? 6. And these are 2 iodo groups. So find and name my substituent. I guess I can put down my parent chain here with my 6 carbons is a hexane. I got my 2 iodo substituents. And if I number my parent chain such that I have the lowest number in the name, I would go from left to right here. All right, but now we have these 2 identical substituents. So what are we going to use in our name here? Comma. We're going to use a comma, yeah. So we're going to include the locant of both of them. All right, so absolutely this would be 2, 3. All right, but then what prefix do I put in front of that iodo? Di. All right, so this is for identical substituents. Let's go back up to our assemble the name portion. So our identical substituents, we're going to use these prefixes. Di, tri, tetra, penta, hexa, and that's good. All right, so just note when it was number of carbons, it was pent. If it's number of substituents, it's penta. We retain the A on the end. All right, in this case, we have 2 of them, so we would refer to this as a diiodohexane. Okay, again, I put the locant of both of them, so 2,3 diiodohexane. Cool, so everybody take a second, do this second one on your own here. All right, I got these 7 carbons in my parent chain, so my parent chain is a heptane. I have these two 1-carbon alkyl groups here. So this one's a methyl group. This one's a methyl group. All right. When I number my parent chain, I'm going to have the lowest number in the name. They both are located at carbon 3. And everybody forgets that we need to include the locant of both of our substituents, even when they're on the same carbon. All right, so my correct name here would be 3,3-dimethylheptane. Everybody forgets to put the two, over here it made sense. They were on different locants. We put them both in the name. When they're on the same carbon, everybody forgets to put both of them down there, right? So remember, we got to include the locant of both of them. So 3,3-dimethylheptane. Okay? Cool. So last complication I can throw at you. Let's do a 9-carbon parent chain. We haven't done one of those yet. Again, we had this 9-carbon parent chain. So my molecule here would then be a nonane. Rather, my parent chain would be a nonane. All right, we talked about our halogen substituents here. This one's a chloro group. This one's a bromo group. But now we're going to number our parent chain. So I'm going to go from left to right. And then I'm going to go from right to left. All right. And so here's our last complication that I can throw at you. If we look at both of these numbering schemes and we list, in our blue numbering scheme, we're at a 2 and an 8. In our red numbering scheme, we're at a 2 and an 8. So in this case, we have a tie between these two numbering schemes. How do we break that tie? Alphabetical order. There it is. Yeah. So if and only if you have a tie in your numbering schemes, you break that tie with alphabetical order. All right? Remember, your first goal in life is the lowest substituent the lowest number in the name. That's the first goal. If and only if you have a tie, then you break that tie with alphabetical order. All right? So if we have a tie, we're going to break with alphabetical order. Okay, so going back to our numbering schemes here, we had a tie. We're going to break that tie with alphabetical order. So I'm going to pick the red numbering scheme because that puts my bromo group, which comes first in alpha order, on the lowest number. So 2 bromo, 8 chloro, nonane. Cool. All right, so now we're going to move on to cyclic alkanes. Let's get a few examples down. All right, so we have a few special considerations for our cyclic alkanes. The first is actually in that very first step where we find our parent chain. Okay. So we're going to say for cyclic alkanes, first we use cyclo at the beginning of our parent chain. The other consideration regarding your parent chain with cyclic alkanes is the ring is always the parent. So it doesn't matter if there's a longer carbon chain as your substituent, the parent chain in your ring, or in that cyclic compound, is always the ring itself. Now, truthfully, there's some exceptions to this rule. This word always, I'm lying to you a little bit. But I'm not really a big fan of teaching you rules and then a bunch of exceptions to those rules, so we're just going to stick to this case where it is always the parent chain. All right, so in this case here, again, my parent chain is that ring. I've got these 6 carbons, so your hexagon here is cyclohexane. All right, in our next example, what's our parent chain? Cyclopentane. And this thing here is this 1 carbon alkyl group or a methyl group. What makes rings a little bit of a pain in the butt is when we get to that third step, the numbering of our parent chain. We can start at any point on that ring. Right? So in this case here, this carbon where my methyl group is, what am I going to call that carbon number-wise? Carbon 1. Okay? If I moved my methyl group over here, does that put it on a different number carbon? No, I would just start numbering at that position. So if we only have one substituent, we actually don't bother putting the locant into the name at all. So this molecule here is simply methyl cyclopentane. All right, so again, special consideration here for when we assemble our name. I'm going to sort of add another addendum here to our assemble name rule. Again, if we have a cyclic alkane with 1 substituent, we're going to ignore our locant. It's always going to be a carbon 1. All right. Now, this caveat here of 1 substituent is really important. As soon as there's more than 1 substituent, you do have to build those numbers into your name. You have to indicate the spacing of those different substituents. But if there's only 1, we know it's on carbon 1. We don't bother repeating that. All right. So then everybody take a second, using that logic, do the name of that last compound here. All right, what's my parent chain? Cyclobutane. I got two types of substituents here. I have an alkyl substituent that's 2 carbons long, so this one's an ethyl group. I have that halogen substituent, my fluoro group. All right, but now I'm going to number my parent chain here. And everybody's always like, is it clockwise or counterclockwise? Importantly, there is absolutely no rule regarding clockwise or counterclockwise, right? It's important to remember that these molecules do not live on the page as 2D structures. They are 3D objects. And if I take this thing and flip it over like a pancake, it's still the same molecule. It's got to have the same name. So there's no counting it one way or counting it the other rule. That's not the rule. It's the lowest locant in the name rule, all right? I can start at either point, so I could go 1, 2, or I could start at my fluoro group 1, 2. In both of these, I have a tie. So how do I break my tie? Alphabetical order, right? So there's no clockwise, counterclockwise rule. Our rules are the exact same as it was previously, all right? In this case, I'm going to break my tie with alphabetical order, so that fluoro group's going to come after that ethyl group. Right, so this would be 1 ethyl, 2 fluoro, cyclobutane. Yeah, cyclobutane. Cool? All right, so we got our rules here. We got all of our special cases. We're going to find our parent chain. We're going to find and name our substituents. We're going to number our parent chain, and then we assemble it all together. All right? And what we're going to do for each new functional group that we encounter, we're just going to update one of these rules, maybe 2 of these rules as we go forward. We got the same base structure for nomenclature throughout. All right? I'm going to throw 2 little challenging ones at you so we can have these in our notes. One, the challenge being that drawing a 7-membered ring is a huge pain in the butt. That's actually pretty good. Yeah, it's a pain in the butt. Anything greater than 6 is kind of difficult, to be honest. 9, I'm not even going to attempt. All right, so these ones are a little bit more challenging. It's the same set of rules that we're applying, but we can get a little tripped up here. So for this one, my parent chain is the ring. That's three-membered ring here. So my parent chain is that cyclopropane. I've got these 1, 2, 3 methyl groups here. The hard part here is the numbering, all right? So I can either say this is carbon 1 and this is carbon 2, or I can go the other way, 1 and 2. And which one of these is going to be correct is a little bit hard to see. What we want to do is do what we said. We're going to list the numbers that are going to appear in our name. If I pick the red numbering scheme, it would be 1, 1, 2, right? Because I got to indicate the position of both of those methyl groups. But if I choose the blue numbering scheme, it's 1, 2, 2, right? So again, list the numbers in the name. It'll make it easier to see which one is correct. Which one am I going to go with here, red or blue? Red, right? Because I want that lowest number in the name. It's that middle column here that's going to break that tie, all right? Or I guess not really a tie, but it's going to make me decide. Cool. So when I do my name here, it will be 1, 1, 2, trimethyl cyclopropane. Okay. My last example here, remember the ring is always going to be our parent chain here. So even though this thing down here has a higher number of carbons, it's still going to be treated as a substituent in my naming scheme here. So my parent chain is my cycloheptane. Let me just move this to a different place. I forgot one. All right. This substituent down here, or rather this alkyl chain down here, again is going to be a substituent. It's got 8 carbons, so this is an octyl group. We got our chloro and our bromo group. All right, and again, what's going to make this a pain in the butt is the numbering of this ring. Because I could start here and I could number going clockwise and counterclockwise. I could start here and number going clockwise and counterclockwise. Or I could start here going clockwise or counterclockwise, right? So there would be 6 possible numbering schemes that I could use for this molecule. Only one of them is correct though, all right? And that is the one that again gives me the lowest number in the name, which would be starting here and going up this direction, all right? 1, 2, 4 is the lowest numbers that you can have in your name. You can kind of convince yourself by doing the other ones, but yes, this would be our correct numbering scheme here. When I'm putting this all together, I'm again going to put it in alphabetical order. So we got our 2-bromo, 4-chloro, 1-octyl, and then our parent chain, cycloheptane. All right, 2-bromo, 4-chloro, 1-octyl cycloheptane. Rolls off the tongue, right? If anybody's got a new puppy and they're looking for a name, right? Great name right here, okay? But yes, that's how we go about our nomenclature. And again, we're just going to kind of build off of these rules going forward. Once you get these base rules down, it's really, really easy to move forward and build off of those. Again, this tends to be where people kind of clean up on points in the course. So get really good at your nomenclature because those are going to be the easiest points that we have available. All right. As I said, next week, we're going to do what are the hardest points that are in the course, and that is our electron pushing arrows that we use in our reaction mechanisms. All right. It's a good idea to review. Mechanisms tend to be a hard part of the course, and they play an increasingly important role in the second semester compared to the first semester. All right. Cool. Enjoy your weekend.